Hi, and welcome to the Australian Water Schools webinar series. Today we are going to be introducing Python scripting for water modelers. Now, Python scripting is coding, it's computer coding. We are bringing nerdy back. My wife got me this t-shirt a while back, and it is appropriate for what we're talking about today. We are diving into the code. We will show you a few things on the background for Python scripting. Where do you start? How do you get started into it? I think a lot of us have heard about others doing it. Maybe some of us have done it on our own and are just interested in new applications. But today we're going to be introducing the topic and finding out from you, the audience, what you want to hear about next and what specific applications you'd like to see. We have our expert presenter, Kevin Nebbiolo from Kleinschmidt, doing our main presentation today. And in the background, we'll have some other experts on board answering your questions on the Q&A line. But let's look at the attendees. Those in the US may be out running around to the polls at the moment, maybe not attending live. It is election day over in the US at the moment, but we've got a global spread. Look at these attendees from all over. So we're excited to have you on board today and excited to hear from our presenters. With no further ado, let me introduce our speakers today. We've got Kevin Nebbiolo from Kleinschmidt, who is going to walk us through some applications. And we also have on the panel Luke Peters and Chris Turnage from Cyro. So let us know where you're coming to us from, where you're sitting right now. And I guess my first question is, how long have you been using Python? First over to you, Kevin.
Sure. Morning, everyone, I believe, there in Sydney. It's 5 o'clock here the day before. So I have actually been using Python now for 5 years. Picked it up in graduate school after teaching myself how to script R, and it's been nonstop ever since.
Great. Over to you, Chris.
Thanks, Craig. Yeah, my name is Chris Turnage. I'm a hydrogeologist at the CSIRO in Adelaide in Australia. I've been working in my role for about 10 years. I started out using Excel and Fortran, and then a guy named Vincent Post gave us a course on Python at our site about 7 or 8 years ago, and I've been using it ever since, and it's made my working life a whole lot easier.
Great. No, appreciate that. Luke.
Hey, Craig. I'm a colleague of Chris, so I'm also with CSIRO in Adelaide. I basically been using Python for about 10, 12 years now. I started using MATLAB during my PhD and then drifted into Python, and especially since it's open source, it's really great to use. And as Chris said, it made my working life so much easier. Great.
No, appreciate that. Now let's, before we head over to Kevin, let's just have a look real quick at the poll results. We've got a significant number, as typical in commercial and consulting. Spread, this is actually a much heavier academic background than we typically see. And again, the main question for us on this content was, are you familiar with these programming languages like Python? And it looks like we're just about split evenly. And speaking of poll results, we'll be seeing these red and blue poll results coming across the lines over the next few hours here. It's right down the line, but a few more that have experience than no experience. And then it looks like Python is leading the way on which languages people are familiar with. Before we head over, and any comments on those, any surprises to you, Chris, Luke, or Kevin, on those poll results?
I'm encouraged to see a lot of folks who have Python experience already. That's good. Hopefully, I am not speaking to too much of a novice group here, because we're gonna throw a lot of stuff at you. But I think with this much experience in Python with the group, and also previous experience with other programming languages, we might not have to spend as much time on some of the nitty-gritty details. So feeling pretty good about that.
Sounds good. Chris, Luke, any comments?
Just happy to see that there's so many people with using statistics. And that's one of the main areas I've been using Python for.
That's good.
Just echo what Kevin said. Really, if you have any background, a lot of syntax, a lot of concepts transfer over really easily to Python. So it really helps having some background at all. It still helps.
Yeah, sounds good. Yeah, well, great. We want to take as much of the session as we can to crank out all that we can. And just keep in mind at the end, we will ask you a question about whether you want more of this. So as you're seeing this, some of this might go right over your head if you are brand new to this, but keep in mind you will have a recording link so we can slow it down and stop it and pause it where you need to. And what we will be offering you in the end is a course where you get to do this yourself. So you'll see Kevin do some pretty cool things here. If you want to be able to do this on your own computer, execute the scripts yourself for whatever application you want. Give us the feedback. Let us know what application you'd be interested in, surface water, groundwater, what do you want to use Python for? And we will tailor a course around your feedback. So you tell us what you want to use it for. We'll tailor a course around that. And then if you see something cool that Kevin's doing and you'd like to be able to do this on your own machine, it's a powerful tool. And let us know, and we will send you a link to a course where you'll be able to do this all on your own with live instructors helping you out, where if you get stuck, you're not just Googling how to solve it. You've got a live instructor who can log on, check onto your page where you can do web screen sharing. This is how we do our online courses these days, and point you in the right direction and make sure we get your questions and any issues resolved. So it's an exciting time in online training. Take advantage of it if this is something you want to do. So I'll drop off on the video. We'll come back on when you're done, and we'll have some Q&A time with the other presenters. Thanks a lot.
Excellent. Well, thank you very much for the introduction, Craig. I'm Kevin Nebbiolo. I'm a data scientist at Kleinschmidt Associates. I am not an H&H engineer, so I'm a little bit different, coming from a different domain, but we're speaking the same language, and that's Python. Let's get into it. So for today's presentation, there's going to be a number of themes that we're going to be talking about. We're going to introduce Python for those on the phone today that don't know what it is. Then I'm going to introduce some areas where you could go for help. Then I think easiest way to start is the way that I'm going to propose it here. And then after that, we're going to jump into the Python syntax itself. Now, there is some prior experience here with Python, so this material might be redundant for some folks on the line, but I'm hoping that you might learn something new as well. But we'll talk about data types and structures, program flow, how do you make the computer make decisions for you. And then I will discuss some modules that I think are useful for water modeling and water resources. And then we'll finish out the presentation with a brief example to create flow duration curves. So, introduction to Python. So what is Python? Well, it is a powerful, object-oriented, open source, easily extendable programming language. So what that all means is that it's free for you and me to go in and use. It's what open source means is we can actually look at the source code on the back end, and that makes our methods very transparent because we are showing everyone in the world what exactly our code is doing. There's nothing to hide. Python is easily extendable. If we don't have a functionality in the basic Python language available to us, we could easily import a piece of software that someone else has written and use that new capabilities in our current script. So Python is different from R. They're kind of the same, but very different at the same time. Python is more of a general purpose programming language. You could code a video game, you can build a website, you can create a database or any other type of application, or you could do data science projects, or you could do scientific and mathematical programming. Whereas R is kind of a finishing language that's mainly for statistical analysis. What I like about the Python language is that it's elegant and has an almost natural language syntax. And this makes the code very readable. I could go in and even novice users, once they understand the syntax, you could literally read a Python script like a page in the book and interpret it. So it's very user-friendly, it's very readable, and it's very approachable for a programming language. Python is interpreted unlike Java or C, which is compiled. And this makes Python programming very easy to prototype. It's easy to just bash out a script, work out a process, and make sure it works without having to fix all of those bugs at the end like you would do with a compiled language. And what's also nice about Python is that it runs on all desktop operating systems. So if I was to write a script in my Windows PC, I could give it to my friend over here who's running a Linux box, and the script will run on his computer, assuming that he has all the modules and the extensions on his computer. But in most cases, if you're doing data science applications, you would have the same pieces of software. But where to go for help? So this first link here is to the Python org itself, where you could get a number of documentations and also community forums where you could post questions and get answers. There's also online courses like Code Academy or Udemy. Oftentimes, these courses are actually free for you or me to attend, and you could learn a little bit more about this Python syntax. You could go really deep into it, or you could learn how to implement data science practices into your workflow. There's a course for everything. And if you don't like either of those options, if you are a bit of a masochist, you could go online and attempt to get your questions answered in an online forum like Stack Overflow. What's great about Stack Overflow is someone has probably already asked your question online and gotten an answer. So you could Google it and figure it out. And those are the three main places where I go for help and learning resources for Python. So for me, the easiest way to start is to download what's called the Anaconda Individual Edition. And the Anaconda environment is a development environment that makes working in Python easier. And Anaconda is specifically suited to data scientists. So it has a number of packages built in that allows you to do data analysis and manipulation and modeling much easier than another standalone development environment, for example. Anaconda is open source. Again, I could go and look at the back end of all that code and change it to my heart's desire. It's very easy to manage multiple environments. Anyone out there uses the new ArcGIS Pro, that's actually a Python application. And you can manage that environment within Anaconda. You could also manage your R environments if you happen to do a lot of statistical programming. As I've already kind of pointed out, it's very easy to manage packages with this built-in environment called Conda. If I want to install a piece of software from the internet, I simply say Conda install pandas or Conda install NumPy. Those are two pieces of software we'll talk about in a second. When you get Anaconda, you also get access to the Spider Interpretive Development Environment. That's what IDE stands for. And with Spider, you get advanced editing capabilities. You have tab completion. You actually have interactive testing and debugging as you are writing code. You'll get messages that come up and say, there's a syntax error here, you need to fix it. There are introspection features that allow you to inspect your variables. And we'll get into what a variable is in a second, but you could have a variable that is, for example, a large matrix, and you can view that in Spider. You can just say, let me see what the matrix looks like, and there it pops up. And then you also get access to the Jupyter Notebook environment. And as it turns out, this presentation that folks are seeing today is a Jupyter IPython notebook. So this is actually has live code that we are going to be able to interact with later on in the presentation. And folks could download this Jupyter notebook on my GitHub, connect to the data that I used, and mess around with it as you see fit. So with that, that's kind of the introduction to Python. And from here, I wanted to start to drill down into the actual syntax itself. So the Python syntax has structures that are equivalent to the English language. This table below here has a number of language structures and their Python syntax equivalent. So in the English language, we have a sentence. In the Python syntax, that is known as a statement, and that is a complete computer instruction. In other words, you could write a computer instruction that says, open this file, or perform 1 + 1. That is a complete computer instruction. It's a sentence. In the English language, we have nouns. In the Python syntax, those are known as objects. And an object could be any piece of data. It could be my name, it could be the number 5, it could be a matrix. That is an object. In the English language, we have adjectives. In the Python syntax, those are known as properties. And properties simply describe an object. For example, the car could be blue. It could have a V8 engine. It could be a Volkswagen, for example. And then in the English language, we have verbs. And in the Python syntax, verbs are known as methods. And those are any actions that an object can take. For example, you could have an object that is a car. You could start the car. You could turn off the car. You could turn on the car's windshield wiper blades. These are all things that you can do with that object. Those are known as methods. So with that, we'll get into creating variables. Again, variables are a piece of data. It's an object that we want to save into the computer and to be able to do stuff with. So variables are names that are given to objects. And when a variable statement is run, that named object now exists in RAM until we remove it with the delete command. Now we have to be very careful here how much stuff we shove in RAM. This laptop that I'm talking to you folks through today has 16 gigabytes of RAM, and you'd be surprised at how quickly you could fill up 16 gigabytes of RAM if you're not careful. When a variable statement is run, we can then insert that variable and the object it represents into mathematical equations. This is known as variable substitution. This is very powerful. And when a variable statement is run, we can reuse and we could update that variable as many times as we want until we delete it and we remove it from RAM. To create a variable, we have an example here right below. To create a variable, we first specify the variable name. In this case, our variable name is going to be called country. And then we follow that variable name with an equal sign. And then that equal sign is then followed by the definition. And in this case, we're going to be country is equal to Japan. And when we want to print what that variable is, we get Japan. This is a Python code. It's a complete Python statement. Naming objects. There are a number of rules that Python imposes what you can and cannot do in order to name an object. Case matters. You can actually name everything in your Python code like that with mixed upper and lower cases, but don't be that person. You won't win many friends. Variable names, they can start with a letter or an underscore, but they can't start with a number. That's important to know. Variable names can contain letters, digits, as in numbers, or underscore. However, variable names cannot contain a space. So if you have a variable name that might be 2 words, you would have the underscore in between both words. You can't use reserved words in a variable name. These include and, or, delete, for, if, print, try, except, and a few others. You'll know in a Python interpreter if you happen to code in a reserved word, because in most Python interpreters, that word will then change its font style and color, and all of a sudden things are different and weird, and I can't use that word anymore. It means something special to Python. Variable names can't contain quotes. Quotes are important. When Python sees something encased in a quote, that's something else. That's now a string. It's not a variable name. And then variable names can't contain any special characters other than an underscore. For example, like an exclamation point that cannot appear in a name. So what can we do with variables? Well, anything that you want to do. This is really the power of programming here. We could use variables within a statement instead of the object itself. This is variable substitution. We talked about this briefly earlier. And this allows us to do things like construct complex mathematical equations. In this, we have a very simple one here. We have as x is equal to 5, y is equal to 12. Well, what's x plus y? It's 17. We can develop much more complex mathematical expressions than this, and we'll see some of the operations that we could do with numbers coming right up, actually, because with this, our discussion on Python variables is complete, and now we're going to go into basic data types. We're going to talk about numbers and strings and a few other types of data types and collections. So numbers are our first basic data type. And when you are dealing with the basic Python language and syntax with no added extra modules, you can use integers or you could use floats. So integers are whole numbers like 1, 2, or you could work with floats, and those are decimal numbers like 1.5 or 1.7. You can construct mathematical expressions that include both floats and integers. However, the output is always going to be the most complex. And we'll see what this means in a second. And as I've alluded to, you could incorporate packages like NumPy, SciPy, and SymPy for symbolic Python to offer other number types into the mix. These can include booleans, 1 or 0. These can include complex numbers, as well as arrays and matrices if you need to do any linear algebra work. So as I said, you can construct expressions that contain both floats and integers. However, the output is always going to be the most complex number. So if you have a float and an integer in an expression, the result will always be a float. However, if you have an integer and an integer in that same, or in a different expression, the output will always be an integer. So this is something that you'll just have to keep in the back of your head. Sometimes you want that float, and sometimes you don't need the decimal point, so you have to be careful. You can do lots of things with numbers here: addition, subtraction, division. That double division there, that's known as integer division. And then you also have multiplication and exponentiation as well. And with other applications like NumPy and SciPy, you have more complex operations that you can perform as well, including deriving functions with things like SymPy. So with that, the numbers, we could talk about strings. So a Python string is anything that happens to be enclosed by quotes, and that's simply treated as text. Now, strings can contain letters, symbols, numbers, reserved words, special characters, essentially anything. If you put anything around that quotes, Python is going to believe that entire thing is its own entity. It doesn't contain any special meaning in it, nor does it do anything. It's its own thing, right? So if you want to create a string, you can surround it by single or double quotes. It doesn't really matter, just be consistent. So if you start the string with a single quote, end it with a single quote. Likewise, if you start it with a double quote, end it with a double quote. Why can you use both single and double quotes to enclose strings? Well, because sometimes you have a quote within a quote, and you need to actually differentiate that. So that's why there's different ways to encapsulate strings. Here we have an example of a string. Again, we could enclose anything in quotes, and that entire thing is this one string object here that we have named a variable name of str1. We can insert special formatting commands within a string itself. Backslashes, as we see here, have special significance to R because that backslash tells R to insert a formatting command into that string. And we're going to see what a \n and a \t does in a second. So that backslash followed by a specific letter specifies the command to be performed. So Python is going to assume that it needs to do something. So we see here that when we have that \n, that actually inserts a new line. And we could see what happens here. We have this string that is all on one line, print in parentheses, line 1, \n, line 2. But when you print it, when the computer compiles it, prints it out as line 1, new line, line 2. So that's pretty cool. That \t inserts a tab. And we can see what happens when we have the \t and a \n within that same Python string. We could have actually very complex formatting. The \n and \t isn't the only formatting characters out there. I encourage folks on the call today to look at the Python.org website to figure out all those commands. Sometimes we need to disable this. Sometimes we're importing data from on disk that happens to be at a directory. And in a Windows PC, your directories are separated by a \. Unfortunately, if you have a backslash there, it's going to think that something's going to happen, and it's not going to import that directory correctly. So there are a couple ways around it. You could either put an R on the front of your string if you want those backslashes to stay backslashes, or you could use a double backslash in the string. Either way will allow you to connect to your data. And then strings are sequences. Sequences in Python are ordered collections of items. And we can retrieve characters from that sequence by specifying a position. And we'll see what this looks like in a second. And what's important to note that Python starts counting at 0. So we'll see what that means now. Here we have a string. It's a name, that's my variable, equals Tim Smith. That is my entire string. And now I want to retrieve a single character from that string. In this case, I want to retrieve the first character from that string. Python starts counting at 0. So when I say name, give me the 0 indexed character from this string, it returns T for the first name in the name there. Likewise, I could retrieve other sequences of characters from that string. There are many things that you can do with strings. You could have all lowercases, all uppercases. You can replace words or characters themselves in strings with a replace command, and you can even split that up. In this case, we split by spaces here. These aren't the only methods that one can do with string. I encourage folks out there on the line to go to python.org and see all the potential string methods that are available. So with numbers and strings, those are our basic Python data types. Again, there are more complex data types that we can bring in with NumPy or SymPy or even pandas. But from here, now we're going to discuss basic data collections. So what's a data collection? Well, essentially, that's a Python object. Again, we just saw what an object was. So a data collection is a Python object that holds multiple pieces of data. This could be a list of names. It could be a list of files in a directory. It could be an array of data from DreamGauge. Now, these data collections, these objects, are created when the script is run, and they exist in RAM. So if you have a list of, say, for example, data from stream gauges, you could have potentially gigabytes of information within that one list. And that's very powerful because now you can do operations to all of those members of that list in once with more advanced programming capabilities. Python has a number of basic data collections that each have their own properties and their own methods. So we could do different things with different data collections. And the ones that we're going to talk about today are lists, dictionaries, tuples, and sets. But there are other data collections that are very powerful, could potentially touch on later in other courses. And these are advanced data structures that you could access through NumPy, SciPy, or pandas. And these are arrays and matrices to do linear algebra operations, or a pandas data frame. And you could think of pandas data frame as like an Excel spreadsheet. You'll have columns of data, and you can perform mathematical operations on those columns. You can perform logical operations. It's really, super powerful what you could do with some of these advanced capabilities. But that's a little bit more advanced for this topic today. So we're just going to stick to the basic Python data collections. So with that, we'll get into what is a list. So a list is simply a container where our objects are separated by a comma, and the entire list itself is enclosed in square brackets. Within a list, objects are ordered, and we can place an order onto them. We could sort a list, for example, and we can change items in that list. We could add items. We could delete items from that list. We'll see all the things that we could do with lists in a second. What's nice about lists is the data types can be mixed. Lists can contain numbers, they can contain letters, they can contain other lists. We can have a list that contains data frames, for example, or a list that contains network graph objects. Really anything you want to put in a list, you can. So that's what's really great about Python. What's also nice is that items within a list don't have to be unique. So say, for example, I have a list of names of people taking this webinar today. Chances are there's more than one Kevin who have signed up for this list. So in a Python list, I could have two Kevins. It's not like the Highlander where there could only be one. So with that, let's get into a list and let's see what we can do with it. We'll have this first list here. This list is L1, and we could see that this list contains these following alphanumeric characters. We have 1, we have a string A, and then we have 3 and 2 4s. And we could see here that nothing here violates Python. We can have numbers and strings. We could also have any other thing that we want in the list, and it doesn't have to be unique. Lists, like strings, are sequences. We can take specific items from that list and then do something with it. For example, this statement here on line 22 simply says, let's print the second value from that list. And here, well, this would be the third value because Python starts counting from 0. Yeah, there you go. So the third item on the list here, even though it's Python index 2, comes out to 3. So again, that's how we extract things from lists. And now that we have that, we could even make this an object in itself. We could say L1 underscore 2, the second object in L1, and that could now be a new variable that we could do things with. So we could build lists all at once. We saw that earlier. We could build a list right now. In this case, list 2. This is 1, 2, 3, 4. And let's print out list 2. There it is, 1, 2, 3, 4. We could easily add stuff to this list with the append command. So let's just append puppy now to this list. There it is. And then we could insert items at any point in this list. In this case, we want to insert the string red in the 4th position, or in other words, the index number 3. And here we have it here. There's red. We can also delete items for a list. We could delete the entire list together all at once by just saying del L2, or we could say, I just want to delete the first item from this list. And when you do, you'll note that our list is now 1 item shorter. So with that, we'll get into dictionaries. This is another type of data collection. Again, another a container to hold stuff in Python. So dictionaries are a collection of objects that is unordered, changeable, and indexed. Dictionaries are enclosed with curly brackets, and they have a colon separating a key from its value. So what does that mean? Well, we have a dictionary here. It's called car. And we could have a number of properties about that car, right? We could have the make of the car. We could have the model of the car. We could have the year that that car was built. In this case, our card is a Ford. It's a Mustang, a Ford Mustang that was built in 1964. I don't know if Mustangs were built in 1964. I kind of pulled that number out of the air. I hope I'm right at this point in time. But here's our dictionary. And what it means is that what no duplicate keys mean is that we can't have 2 makes for the same car. For example, it can only be a Ford. It can't be a Ford and a Volkswagen. So that's what no duplicate keys mean. So in other words, this is pretty much a hash table or a table in a relational database. You could think of a dictionary like that as well. So when we print the dictionary, this is what it looks like. Now we can do many things with dictionaries. We can obviously print a specific property of that dictionary. In this case, we want to print the value of the make. In this case, that's going to be a Ford. We can also change the values in that dictionary by specifying this command right here. So my year of the car is now 2018. It's no longer 1964. And when I print my dictionary, you'll see that final property there has been changed now to 2018. So again, we can do many things with dictionaries. Again, please check out the python.org website to figure out everything that you can do with dictionaries. Next, we have tuples. Again, this is another container of data, container of stuff to put your stuff in Python. So a tuple is a container of objects that are separated by a comma and enclosed in parentheses. And the first time I looked at a tuple, I said, well, geez, that's a list, right? Why is it different? It looks like a list to me. It behaves like a list, except it's what's called immutable. And that means that we cannot iterate over the individual elements in that tuple. It comes all at once, and that's it. So say, for example, we have a XY coordinate pair as position 100, 200. When we call position, it comes all at once. We can't say, let's do this to the X position and that to the Y position. It's its own thing. We can't iterate over each one of those objects. And then the final data collection that we'll talk about today are sets. Now, sets are unordered collection of objects that are separated by a comma and enclosed by a bracket. And again, you're saying, Kevin, man, that looks like a list, but it's not. It's not a list. Sets are primarily used to to eliminate duplicate entries. So a set is different from a list in that it doesn't or it does not allow for duplicate entries. So we have a new list here, list 3. It contains apple, orange, apple, pear, orange, and banana. And when we say, give me the set of that list L3, it's only going to return the unique individuals. In this case, apple, orange, banana, and pear. And that's great when you have a big, massive list of hundreds of thousands of objects, and you say, just give me the unique objects in this list. Just say set that list, and everything will compile for you within seconds. It's optimized. It's great. I love that. So with that ends kind of our discussion on basic Python data collections. Now we're going to get into program flow. Now we're going to really learn to teach the computer to do what we want, to make decisions for itself, to automate processes. This is where we get to really leverage object-oriented programming languages to do what we want and make our lives simpler.
And Kevin, let me just, sorry to interrupt here, just as we move on to this next topic, just really having a look at the Q&A line and some of the questions that have come in there. Just encourage everybody to put your questions in there. Some of them have been answered already. Some are still open. Upvote the questions that you feel need special attention. And I know some have asked, hey, we wanted to see hydrologic applications. We do have some of that coming, a very brief overview of what we might be able to do. Thanks for your patience for those who already know the basics. What we are requesting from you is if you could please just let us know what applications you want to use it for. If you've come online looking to do something in hydrology, we will cater a course around that and allow you to do that. We'll probably just be able to touch on a couple of basics here, going to still leave a little bit of time for Q&A. But just wanted to let everybody know that we will be walking you through some hydrological applications. Just briefly touching on it today, but we will have a course focused on that. So, Kevin, yeah, we'll probably have about 5 to 10 minutes here of presentation time left, and we want to leave a few minutes for questions as well. But thanks for the information so far. This has been a great overview. So back to you.
Thank you. So with that, we'll get into program flow. So loops. A loop is a statement that repeats itself until some condition is met. For example, we want to iterate over files, a stream gauge files in a directory because we want to calculate metrics for an entire watershed, for example. So we have downloaded all these stream gauge data. They exist in separate comma delimited text files. Well, I could just write a loop that iterates over each file in a directory and does a specific operation to each, then compiles all the data and processes the final statistics. So we do that with a loop. The first loop that we're going to talk about is a for loop. So for loops iterate over items in a list or keys in a dictionary to perform some type of task, like I was talking about, like iterate over each file in a directory and compile these statistics. So each one of those tasks runs once for each one of those items. So for example, here we have an example of a loop, a for loop for every item in this list. We are going to figure out its logarithm. So that's what it is. That's our for loop there. We also have other types of loops called while loops. Now, while loops will run until some sort of test condition is met and it stops. It is important to note that you can create instances of endless loops, and your computer will just go until you actually unplug it and stop it from working anymore. So just be careful that you can actually meet that test condition that stops your loop. And I'm sorry for going so quickly through some of these slides. I really want to get to that application. We can allow the computer to make decisions for us with if statements. So if statements allow a script to test conditions. So if a condition is true, then we are going to do this. If statements are compound statements. So we have a statement here. We have a variable called x, and we have given it a number. It's x is equal to 2. And our conditional statement here says is if x is less than 5, we're going to print the word true. And as it turns out, x happens to be less than 5, and it's true. So that's how an if then, yes, an if then statement works. What happens though if there is more than one criteria? Well, we can incorporate an else if statement or elif. So we could see here, if x is greater than 5, print value is greater than 5. Else if print value is less than 5. So if we have a value of here of x is equal to 2, it's going to print out that value is less than 5. And then what about everything else that we can't fit into one of those two if or elif categories? Well, there happens to be an else container for all of that. So this is what an if else statement happens to look like. So I could provide more examples of these at a later date. There are a lot of conditional operators that Python can incorporate into these if then statements when making a decision. We have equal to, not equal to, less than or equal to, etc. Different type of conditional operators that one can put into those statements. And then we can create custom functions. Now, functions allow you to reuse code that can be called upon at a later point in the script, or you could even save that function to disk and use it in another script at a later time. Say you wrote a brilliant piece of code that did this amazing thing and you want to completely, or you want to use that on a different project. Well, this is what a custom function is for. A custom function is a compound statement that's preceded with a keyword def for a definition that happens to be followed by the function name and all of its arguments. And the remaining statements in that compound statement carry out the actions of the function. In this case, we have created a function for a Fibonacci sequence up until a specific number is met. And we'll see what that looks like here. So we say Fibonacci up until the number 1000, and this is a Fibonacci sequence up until the number 1000. And because it had that while statement in there, as soon as the limit was reached, the loop ended, and the function also ceased as well. So that's our brief crash course into the Python syntax. Now we're going to get into some specific applications for H&H applications. So before we get into that, though, there are a number of Python modules that I think are very useful for the H&H professional. The first one is Pandas. Pandas is a very fast, very powerful data analysis and manipulation tool with advanced time series support. It's probably the most important module or pieces of software that an H&H professional can utilize. You can do essentially anything that you need to do with time series with Pandas. It's easily the most useful module out there. If folks do a lot of work with linear algebra, you will want to utilize NumPy. So NumPy stands for numerical Python, and that's a fundamental package for scientific computing because it implements n-dimensional arrays and matrices. SciPy comes with NumPy, and essentially it does everything that NumPy doesn't. And so it allows you to fit optimizations for numerical optimizations for curve fitting procedures, for example. Any sort of advanced mathematics, cubic spline interpolations, you could do that with SciPy. And again, that's very useful in recreating time series data as well. And then we have a number of standard plotting packages that are useful for the visualization of information, that being matplotlib, which is pretty much a port completely over from MATLAB of that standard plotting language. It brings it over into Python. But then there are also premium plotting packages that we'll get into, like Plotly, that allows you to interact with your data and really incorporate advanced capabilities into your data visualizations. So I have a number of tips that I've developed over the years when writing scripts. I've always viewed that when writing a script, it's like writing down a recipe for someone. Essentially, you are writing down a recipe that you want the computer to follow. So your tools that you would encounter in a recipe, for example, specific measuring cups or like a food processor or blender, for example, those are equivalent to modules. Again, we saw some of those useful modules. Those would be the Pandas and the NumPy and the Matplotlib and what we need to do, what we need to utilize to do our work. And then we have ingredients for your recipe, and ingredients for a script is your data. And we'll see in our example in a second, our data is coming from a stream gauge in Australia. And then the instructions that you write down for the person following the recipe are your computer statements. Now, order of operations is important, just like you wouldn't want to not mix your wet and dry ingredients before putting it in your cake into the oven, right? Order of operations matters. So it's really important that you plan your script well. You want to write it down, plan it out on a piece of paper. And when you do that, you enter into the R environment already kind of figuring out what you need to do. And then you're just kind of taking those steps and you're putting it into that computer syntax that will then allow it to follow it. So, excuse me. The application that I'm going to be speaking about today is a simple one that everyone on the webinar here should know how to do, and that's create flow duration curves. So to create a flow duration curve in my script that we're going to see here in a second, we need to import these necessary tools to work with and plot the data. Then we need to connect to some of that data and pull it into Python. Then we need to perform some data management, some rudimentary analysis, finally calculate an exceedance probability, plot and profit, right? So with that, let's get into the script itself. So the first part of any script for me is to import the modules. These are the tools that I'm going to need to do my job. So I'm going to import pandas for data analysis. I'm going to import Plotly to make a data visualization. And then I'm going to import NumPy to do some large scale array data manipulation, just so I can make things run faster. So my second step in my script is to connect to the data. I need to get my ingredients, right? So I have uploaded information from the Weir River in Australia to my GitHub account. This is that URL where we can find the information. And then I use pandas to connect to that data and to import it all in one step. And pandas has a wonderful method that says read CSV. So I have a comma delimited text file on the internet. I provided it its URL, and I say just read it to me and bring it in. And here it is. I brought it in, and it prints out the first 5 rows of the data frame. From here, we can see that I don't need all of this data. I don't care about the quality code. I don't care about the interpolation type. And I also notice that that timestamp is a little hard to read. So I'm going to do some data management and manipulation here. So the first thing that I'm going to do is I'm going to convert that timestamp to a specific date time object. And so this makes it easier to read, easier to interpret. I know exactly what time it is now. I also don't need those extra columns. So I'm going to now remove them from the data frame. And with these 2 statements, I do all of that work. And when I print the first 5 rows of that data frame, we could see how it changed. So this is the data as it was imported. And this is the data after those 2 statements have been run. And from here, we can proceed to the next steps, which is to rank stream flows. So Pandas has a convenient ranking function that ranks everything, all the values in a particular column. In this case, the value column, which happens to be our stream gauge values. And I'm going to rank these in descending order. So as you see here, this is the actual rank of this flow value. And then from there, we can calculate exceedance probabilities. So I have a new variable, in this case, n, which is the length of my data frame, the number of observations in it. And to calculate the exceedance probability, it's simply 100 times the rank divided by the number of observations. And we could see now here is my data frame with the exceedance probability. And then at this step, it's simply just plotting it, the information, right? Well, I want to do a little bit of sorting first, filtering it, and then we're going to plot. So I'm first going to sort the values by rank. So it starts from the largest rank and goes down to the smallest. Then I want only positive values, because we're actually going to take the base 10 logarithm of this data, and we can't take a logarithm of 0. And when I do that, I could then plot this information. So I have my Plotly graph object here. That's what Go stands for. And my X data is the exceedance probability, and my Y data happens to be the logarithm of flow. Now, what's really nice about Plotly is that these plots are interactive. So I could move my cursor over here and hover and get the actual values along this curve. And this is really useful when we are comparing multiple curves. Plotly also allows you to incorporate a lot of widgets. You could have pull-down menus that filter and restrict this data set even more. And I think with that, I just wanted to show folks that this is the actual curve itself from the Bureau of Meteorology. And this is what it looks like in the Python realization. And with that, Cray, I am all set. I have a link here to my GitHub. If folks want this presentation, they could download it and do whatever they want with it.
Excellent. Wow. That was quite an overview. Thanks so much on the chat line to Luke and Chris, to the questions that have been answered there. Kevin, while maybe we turn the time over to Luke and Chris, maybe have a look. I know you probably haven't had a chance to see what's come in, but look on yours, look at the questions that have been upvoted. We might just, in the interest of time, pick 2 or 3 questions each for Luke and Chris, those that you have answered, that you saw that were upvoted the most, that were of most interest to the whole group. If you can have a look at those, and then just be prepared to maybe address those. Those watching on YouTube won't see those, so repeat the question and how you responded to that, whatever was most relevant. For anybody who needs to run, you will see the poll question come up. Do not exit and leave us without giving us some feedback. We want to tailor these future webinars and the courses around you, around your needs. We've got thousands of people registered for these webinars, and if you leave and don't give us your feedback, we won't know exactly what you want to hear on the next ones. So give us suggestions for topics that you want to know about, the relevant ones in the water industry worldwide that you want to hear about. Let us know. And as we customize this course for you in Python, what do you want to be able to do in Python? I mean, we've seen this overview on how you do it, how an expert does it, but how do you or I, as a novice user, somebody who has never even opened Python, but needs to customize something in your hydrological model, how do you do it from scratch? That's what we're all about, is being able to empower you with that. That's why we put this webinar out there. There's so much you can do with this, so many things you can customize as you get into Monte Carlo analyses and everything else. We want you to have that skill. We want you to have those, have that opportunity to do that. So first of all, over to Luke. What have you commented on that you feel is most relevant for this audience?
Okay. Well, actually touching on what the poll is about. So there were a couple of questions about where can I learn it? How do you use it in day-to-day practice? What are relevant packages? And how do I start? A lot of that, what in the poll, is a bit more specialized topics on where we can give examples in follow-up courses on how to do things. So what Chris and I have been doing in the question and answer is pretty much how I do my day-to-day practicing Python, is Googling a lot. So you've seen that we've posted and pasted quite a lot of links into the chat box. So there were things like so what I often find is that if I have a problem, there's usually already somebody out there who has found a solution for me, or even better, has written a package for that. So there was a couple of questions around what are other Python libraries that we use, except for the ones that Kevin mentioned already. So a couple of the packages I'm using quite a lot is scikit-learn. That's giving you a bit of machine learning and predictive modeling capability. That's a bit more advanced. If you're working a lot with raster data or GIS data, there is Rastrio. And I think Chris also put in there the SciPy package, which is a nice complement to the NumPy package. So all of these things are in the chat box, and we can give you those links afterwards. And were a couple of questions about numerical modeling and calibration of rainfall runoff models. So a lot of these rainfall runoff models have versions in Python. So we pasted some links, like I know the Aura model in Australia has a Python version, and I think there's a couple of other ones as well. And in terms of calibration, there is versions of pests that have a Python interface. There's also the DREAM algorithm from Jasper Vrucht that has a Python implementation. And as I said, if you Google a bit, you'll often find that most of the popular packages, somebody would have ported it to Python or made an interface for Python available.
Great. No, thanks. I think that's a great overview on some of those comments that you've made. And thanks so much for fielding those during the presentation. Chris, over to you. Anything that jumped out at you?
I think, yeah, Luke's covered most of it there, but one other thing that stood out was interest in Jupyter Notebooks. So Python isn't always run through a Jupyter Notebook, and for me, it's something I've only gotten into in the last few years. But the benefit of those notebooks as a communication tool, so rather than just looking at code or just looking at results and explanatory text, the beauty of those notebooks is that they you can combine the two, and you can alternate between text and code, and really when you're communicating your research or your work to someone else, you can sort of, you can show them step by step in a linear way how you've gone about it, and with a lot of explanation, which you don't get from just looking at a code. And the other thing is that they're interactive, or they can be interactive. So they can be run in the cloud with MB Viewer or MyBinder. So if you're presenting that work to someone who doesn't even have Python installed, they can look at the notebook and even run it, if they, change little parts of it and rerun it in the cloud without even having a Python installation on their machine. So that's the beauty of that aspect to Python, which doesn't always have to be used in that way, but it's a real nice way to communicate results and workflows.
Thanks. Excellent. Over to Kevin. Anything jump out at you from the chat line now that you've had a chance to have a look at what came in while you were speaking?
Yeah, a couple interesting questions. First question I got was, is the syntax same across different Python development environments? So someone mentioned PyCharm, and Spider happens to be another one, and then Python notebooks are another development environment. Yes, syntax is the same across all IDEs and all operating systems. That's what's wonderful about Python. I can write something on my Windows PC and I can hand it to someone on a Linux box, and they can run it as long as they have the modules on their computer. It'll work because they could connect to the data all the same. So that's what's great. Then another question I got was regarding tuples, and what the hell are they and what do I use them for? I really don't use them much at all. I only use tuples when I have an object and I want to represent its coordinate, its place in space. So it's like its XYZ coordinate. In graduate school, I developed an agent-based modeling that was dealing with ships in navigational channels. So all of my coordinates, all of the positions where my agents were at any time are always represented by a tuple, because I knew the first element in it is always my X, the second element in it is always my Y, and the third element in it is always my Z, and it doesn't change. So that's really the only time that I use tuples, pretty much lists, and I only use sets when I need to find the unique elements in that list. Really, that's what I'll use those for as well.
Okay, so great. Any final remarks?
For me, this was fun. I saw another project in here about potentially using Python for Esri applications. I think there's a lot of interest there as well. Python now through ArcGIS Online has a notebook server, so you could create these Python notebooks and really incorporate data science into your GIS applications. So I think that's something that I'm really going to be focusing on development-wise in 2021.
Excellent. Luke, final remarks?
That's been pretty full on looking at the questions coming in. Just one more was one of the final questions on FlowPy. So that's a package for an interface to Modflow. That's something that Chris and I have been using quite a lot in our day-to-day practice. So if people are interested, yeah, feel free to hit us up.
Excellent. Chris, final comments?
Yeah, that was fun. I enjoyed answering those questions there. Yeah, it's great to see the interest in scripting using Python, and yeah, there's so much benefit in it in terms of the repeatability of workflows, the transparency of workflows, easier interaction with models and other software. Like Python really works well as a pre and post processing tool. So yeah, it's great to see the interest out there.
Great. So let's look at what's coming up. We've got 2D cell sizes coming up from WBM next week or in the next couple of weeks, and then riprap sizing, some other courses on groundwater and surface water modeling. Join us for those. Thank you so much for attending worldwide. It's great to have this audience with us today, and thanks for all you do to help further the industry and the knowledge in the industry. Thanks, Kevin, Luke, and Chris. We'll sign off from there.
Right. Thank you.